Hi, recall the laws of indices. Remember them? How many laws are there? A very simple 8 laws of indices at your fingertips. Always have them so that you become a master of indices, and it controls, it gives you a very good perception of numbers, and a whole world of numbers will unfold before you. That's what I'm going to do to you today right now to show you what I meant by cousin numbers. But let's start first with the laws of indices. A quick recall. A to the power 0, you get a 1, yes. And any number, if you have the power of negative power, you get it as 1 upon a to the power of n. The third law, yes, is a to the power of m times a to the power of n. What do you get? A to the power of m plus n. The fourth is when you have am divided by an, you take away up power minus the down power. Just remember, up minus the down. The fifth law, a very powerful law, power, power. You get an amn. And the sixth law, if they have the same power, two different numbers, and you're multiplying them up, just put them together, ab to the power of m. And if you look at the seventh law, if you have a to the power of m divided by b to the power of n, you've got the same power. So take that out and you get an a over b to the power of m. The last law, the eighth law, is if you have a to the power of m over n, a rational number, you get it as a to the power of m. This is the power and n is the root. Now that you've got these 8 laws, we've now got to do some worked examples. Just go back to the laws and apply them. But before that, do you know the powers? Do you know the magic of numbers? Let me connect you with that. You found out earlier on that 2 to the power of 12 is 4096. And you also found out, hey, this number 4096 appears in other ways. How else? So let's apply the laws and get back to it. Now 4096, 2 to the power of 12 is 4096. But what is 12 made of? 12 is 2 squared. Remember, times 6. 2 times 6 is 12. And 2 squared, what is that? 4. Hey, 4 to the power of 6. And this is the same as this. And this 4 to the power of 0, 4 to the power of 6 is 4096. Now, can we express 2 times 6 this way? 6 and 2. 6 times 2 is 12. And you can say they're both the same, aren't they? And what is 2 to the power of 6? 2, 4, 8, 16, 32, 64. So it is 64 squared. So 64 squared is none other than 4096. Do you see the magic of numbers unfold before your eye? Let's go a little further. 12 is also made of 3 times 4, isn't it? So 2 cubed, 2 to the power of 3 is 8. 8 to the power of 4 is 4096. Look at it. 4096 is made of these numbers. And we can also say 4 times 3 is 12. And 2 to the power of 4 is 16. 16 cubed is 4096. Now we're now going to create a hamper with 4096. You can see that 4096 is made of a few numbers. And what are they? 2 to the power of 12, yes. 4 to the power of 6. 16 to the power of 3. And you can also see 8 to the power of 4. 64 squared. You can see that all these numbers have the same answer, 4096. And this is beautiful, isn't it? So you could see that 2, 4, 16, 64, 8. There's something magic about it. Because each of these numbers, 4, is 2 squared. 2 times 6, 12. 8 is 2 cubed. 3 times 4, 12. 16 is 2 to the power of 4. 4 times 3, 12. 64 is 2 to the power of 6. 6 times 2, 12. So 4096 is made of this combination. Can you come up with other numbers of such? Can you pack them up into a little mini hamper? Alright, let's look at 1024. What is 1024 made of? 1024. If you recall, it's 2 to the power of 10. Yeah, but 2 to the power of 10 is made of 2 squared times 5. 2 times 5 is 10. And if you look at 2 squared, that is 4 to the power of 5. So 4 to the power of 5 is 1024. And if you put this way, 5 and you put 2, 5 times 2 is 10. And 2 to the power of 5, 2, 4, 8, 16, 32. And so 32 squared is 1024. Can we break 10 in any other ways? No. So we can see that 1024, this is actually made of the cousin numbers 2 to the power of 10. Look at it. 4 to the power of 5 and 32 squared. All these numbers share the same number, the answer 1024. You could think of other numbers too, like 729. What is 729? And look at more other numbers. But before that, I like to go into prime numbers and prime factorization to give you a value-added information on how we could do how we could go deeper into understanding these number concepts.